In this video, I'm going to give an introduction to the standard form of a quadratic function. So, when you're thinking about a quadratic function, you might think, well, we just learned about quadratic equations not too long ago, where it was y equals ax squared plus bx plus c. Okay, if I were to erase the y and put in its place f of x, this is the definition of a quadratic function. So this is a quadratic function. Though this is not the standard form of the quadratic function. So we can rewrite this as f of x equals a times x minus h squared plus k. Okay? And just as long as a does not equal 0, right? Because if a were to equal 0 in either this one or this one, then you lose the square term, so you lose the quadratic part of this function. Okay, so this is the standard form. That is the standard form. How did we arrive at the standard form? Well, it's not too difficult to do this actually, and maybe you should for practice. Go ahead and use completing the square method, and you'll get something that looks, in this format. So, yeah, go ahead and try that on your own. But so this is, this is the same equation, it's just a different way of writing it. So do you notice that this is the standard form of quadratic function? This is a transformation of the function g of x equals x squared. Okay, so this is a transformation of g. We know what g looks like. This just looks, g just is a parabola looking, well, it should go through the, there we go. Okay, it's a parabola going through the origin. So what does f of x look like? Well, we know that so the first part is there's this a out front, and so that's a, what we have going on is some sort of vertical stretching or compressing, depending on if a is a fraction or not. So stretching or compressing, okay, by vertical stretching and compressing by factor of a. And then also, if a is negative, if a is less than 0, then there is also a reflection about the x-axis, right? So if a is 0, then you would be going in the other direction. So I'm going to erase that. I just wanted to show that. All right, and then also we have, what else is going on? So there's also a shift that is moving to the right, okay, if h is positive. So a horizontal shift right if h is greater than 0, and then if h is less than 0, then it's a shift left. Okay, and then lastly, there is a vertical shift up if k is positive. So vertical shift up if k is greater than 0, and then down if k is less than 0. Okay, so, so say h is, some positive number, so I'll just put it out here, and this is h, say, okay, and then k is also some positive number, say it's there. Okay, so we go right by whatever h is, and up by whatever k is, okay, and then we end up basically moving, where we're starting. So this got moved over and then up. So then if A is positive, and my parabola would then look something like this. Okay, so that's interesting, because what that says, so this point, we know what this point is. This is h comma k. Okay, so that means that if I have my function in standard form, I can very easily see what the lowest point on the parabola is. Okay, if the parabola went in the other direction, it would be the highest point. So and this point is actually, that's called the vertex point. So we can easily find the vertex looking at the standard form of an equation. I'm going to go ahead and write these things down on the next slide. Write down these properties. Okay, now let's talk about the properties of the standard form of a quadratic function. First, we know that, the first thing that we know, this is a parabola. So by parabola, I mean, when you graph it, you have this like U shape, either up or down. Okay, so it's a parabola. Second thing that we know is we know the domain. Okay, so the domain for quadratic functions is always, so domain, remember, is what you're allowed to put in for x to get, a real number out for y, or for the function. So the domain for this, it will be negative infinity to infinity. I can put in any real number for x, and I'll get a real number out for y. Okay, next thing I know is what I just talked about, which is that h comma k is the vertex. Okay, and so the vertex is the minimum value minimum value that the function can obtain if a is positive, right? Because if a is positive, we open upwards. Okay, or the vertex is the maximum value if a is negative, right? Because if a is negative, we open downwards. Actually, that's another property that we know. We know that we open up if a is positive, and down if a is negative. Okay, that's due to the transformation. Basically, it's just this is just a that's a transformation property. Okay, and then last thing that I want to mention is we know that the symmetry, or the axis of symmetry, let me write that, axis of symmetry, is x equals h. Okay, that's because, well, so in the previous slide, so here, let me draw this out. Say we were to draw this here, and then we have a parabola that looks like this, okay? And so its vertex here is at h comma k. So we drew something like this on the previous slide. Well, the axis of symmetry is basically where you can fold, the line that you can fold over, and your parabola will line up on itself, okay? So that is right here at x equals h. That's the axis of symmetry.